Okay, how's it going, guys? Today in this video, we're going to be going over 9.1, day 2. So in this video, we're talking about distinguishing between inverse variations and direct variations. And we learned in the last video and also in the first set of notes that an inverse variation, y is going to equal a all over x, right? A is the constant term, it doesn't change, and it'll be all over the variable x. Or in other words, we can rewrite this as a equals y times x. And if we look at that second equation, we're saying a constant term equals y times x. So that's saying no matter what pair of points you choose, you're always going to get the same constant term. Or in other words, the product of variables is constant. So no matter what pair of variables you picked, as long as they're paired together, you're going to get the same constant no matter what. And that's for an inverse variation. For a direct variation, y is going to equal a times x, or ax. Or in other words, a will equal y all over x. All right, if we look at that second equation again, we're seeing a constant term equals y over x, or the ratio between y and x. So that means that the ratio of variables is also constant. Because in a direct variation equation, no matter which pair of points you choose, the ratio, not how I put a ratio, but the ratio between the two variables will always be the same constant. So the ratio of variables is constant. Okay? So let's go on and do an example. So on number 1, we're told the table gives the total cost in dollars of various numbers of tickets to a school play. What is the cost of 12 tickets? So we want to know what C is when T equals 12. That's essentially what the question is asking, and that's what we're going to be working for. But before we can actually solve it, we need to know if it's a direct variation or an inverse variation. And that's why we're going to figure out our product between pairs of points and our ratios between those same variables. So for product, we're going to multiply 3 and 12. That's 36. And then we're going to multiply 7 and 28. That's 196. And finally, we're going to multiply 9 and 36, which is 324. Okay? And we can see that all the products are different. They're not the same product. They're not the same constant. So that tells me that this cannot be an inverse variation. Because for an inverse variation, the product between the pairs of variables have to be the same. Okay, so 3 times 12 has to be the same as the next point, 7 and 28, sorry. And they're not, so that tells me it's not an inverse variation. Let's go ahead and actually check out the ratio. When it comes to figuring out the ratio, the most important thing is to make sure you stay consistent with how you pair them up. It doesn't matter if you do T over C or C over T. It really doesn't matter, but what matters is that you stick with whichever way you choose. If you decide to do C over T, stick with C over T for every single ratio you're solving for, and when you're solving for the problem at the end, okay? So we're going to go with C over T since the numbers come out a little nicer. So we have 12 divided by 3, that's 4. 28 divided by 7, that's also 4. Then 36 divided by 9, that's 4 as well. Okay? So we see that our ratios are all the same. So that tells me that this has to be a direct variation. Okay? So it's a direct variation. So that means I can use the equation y equals a times x. Okay? Or we could also use the other one they gave us, a equals y over x. You can use either one you want, but we're going to use the second one because we solved it. We solved for our 4 with it being C over T. So let's stick with it that way. It's going to be a little easier. Okay? So our a term is going to be our constant term. It's the term we had that stayed the same, or in other words, the ratio. So 4 is going to equal our y term over our x term. And how we set it up, we solved it as C over T for our ratio. So that means we're going to set it up in our problem as C over T as well. So our C is ultimately what we're solving for. And we want to know what C is when T is 12. Okay? That's what the problem asks us for. What C is when T equals 12. So we have it all set up, and all we're going to do now is multiply by 12 on both sides. And we get that C equals 48. Or in other words, To buy 12 tickets, it costs $48. All right. So we're not going to do number 3, but we're going to go ahead and do number 4, or sorry, number 2. That's right underneath number 1. It was on the next slide. So we're going to go ahead and work this one. So this says that the table gives the time needed to drive to a destination at various average speeds. What is the time needed to get to the destination when driving at an average speed of 48 miles per hour? So basically we're asking, what's t going to be when s equals 48? So before we can actually solve for that, again, we need to figure out if this is a direct variation or an inverse variation. So we're going to figure out the product and the ratios. Okay, so for products, we're just going to multiply t and s. So 50 times 12 is 600. 40 times 15 is also 600. And 20 times 30 is 600 as well. So they're all the same, so it's very likely that this is going to be an inverse variation. Let's figure out our ratios as well. So for our ratios, we're going to do t over s. I usually like to have the higher number be on top. It doesn't really matter. That's just personal preference. So I'm going to do t over s. So I have 50 over 12 for the first one. And I can reduce that by dividing the top and the bottom by 2. And I get 25 all over 6. So I have 25 over 6. For the second one, I have 40 over 15. If I reduce that, I can divide the top and the bottom by 5. I get 8 over 3. And lastly, I have 30 over 20, which you reduce it by taking away those zeros or divide the top and the bottom by 10. So it's going to be 3 over 2. We see that all the ratios are different. They're not the same, so that tells me that this cannot be a direct variation, but it has to be an inverse variation. So we're going to use an inverse variation problem or equation to solve it. I'm going to use a equals x times y, but if you wanted to, you could also use y equals a over x, or whatever you like. Okay, it doesn't really matter. They're all the same equation. Choose whichever one you like most. I'm going to stick with a equals x times y. Or in this case, it's going to be a equals t times s, since those are what our variables are in this problem. So our a is our constant term, so it didn't change when we multiplied the variables, so it's 600. So 600 equals t, which is what we don't know, is what we're solving for. And our s is going to be 48, since that's what we are looking for. So we're going to solve for t by dividing 48 on both sides. And when you divide 600 by 48, you get that t equals 12.5. Okay? So that's how you go about it. It's how you will solve any problem like this. For number 3 and number 4, I want you guys to actually do that yourselves. I don't think this stuff's pretty straightforward, so go ahead and try it yourselves. You need to double check yourself. You post a completed key on Canvas, and if you need a reminder how to do it, just come back and watch my videos, see how I do number 1 and 2 again, and try it again yourself. Hopefully this helped, guys.